Hi everyone, today we're talking about ratios. We're talking about what ratios mean and then how to simplify ratios. So first off, a ratio is a comparison of two similar quantities. And a ratio is used to tell us how two quantities are related to each other. This is an important vocabulary word, so this should go into your notebook. A ratio is a comparison of two similar quantities and tells us how two quantities are related to each other. So for example, these are the most popular examples of how we use ratios in real life. We use it when we're telling somebody a score. So the score from the game was 12-11 Warriors. That's usually how you hear somebody talk about scores, using ratios. And usually they'll tell you the winner, the person or the team with the higher score. So here in this imaginary game, the score at the end was 12-11 Warriors. So Warriors were the team that scored 12 points. We also hear it when we're talking about recipes, because recipes are very particular. You need to add in the correct amounts, and in order to create a bigger recipe or a smaller recipe, you use ratios and proportions. So this example, in this recipe, you're using a ratio of 3 cups of sugar to 2 cups of milk. So letting you know how those two quantities are related to each other, whether we're talking about scores and how they're related to each other, or ingredients in a recipe. The key word that you see in both is the word to, because we want to know how they're related to each other. Mathematically, so that's how you would talk about it with words. You say whatever amount to whatever, right? Mathematically, we're going to use the colon, which is these two dots, or we can use the fraction bar. So we either use the two dots or the fraction bar. So in math, we signify a ratio by using the colon or fraction bar. And we read it the same way, a to b, which is the same as a to b written as a fraction. Okay, so those are 3 different ways that you can write a ratio. You can write it with the colon, you can write it with the fraction, or you can write it with words and just read it out, 12-11. Okay, so be sure that this information is in your notes. All right, let's move on and talk about an example. In this example, there are 12 boys and 20 girls in a class. Find the ratio of A, the number of boys to the number of girls, and B, the number of girls to the number of students in the class. Okay, so in this example, there are 16 people who identify as boys and 20 who identify as girls, and we want to find the ratio, their relationship to each other. So let's go ahead and solve A. They're asking us the number of boys to the number of girls. 2 is the key word there, so we know we're going to use ratios. The number of boys is 16, and the number of girls is 20. So we can write it in 3 different ways. We can use a colon, we could use the words to, or we could use our fraction bar. Those are 2 different ways you can write the ratio for A. That's it. That's all they want. Now, you should simplify it, right? So the reason why we simplify ratios is so that people can understand the actual relationship better. If you just say 16-20, people are like, okay, those are just numbers to me. So let's go ahead and simplify that so we can give a more exact presentation of their relationship to each other. Let's see, 16 and 20 are both even numbers, so we can divide them by 2. 16 divided by 2 is 8. 20 divided by 2 is 10. They're still even, so we can still divide by 2. We get 4-5. So we can write it as 4-5. We can write it as 4-5 with colons. We can write it as 4-5 with words. But 4-5 gives us a much better and more exact picture of the boys to girls ratio, right? 16-20, you're like, oh, Yeah, there's way more girls than boys in that class. But if I say 4 to 5, you're thinking, oh, the ratio is actually pretty similar. For every 4 boys, we will see 5 girls. Okay, so it gives us a better breakdown of their relationship. Okay, part B, the number of girls to the total number of students in the class. So we know that there are 20 girls. And now we want to know to the total. Total would be boys plus girls together, 16 plus 20. That would be a 36. So the ratio of girls to the total would be 20 to 36. Now we should reduce that, simplify that by dividing top and bottom by the same number. Let's see, 4 goes into both 20 and 36. Let's see, 5 times and 9 times. So the ratio of girls to the total number of students is 5 to 9. So that's pretty much it. It's basically working with fractions. But since we're talking about ratios, it's not just a normal fraction, but it's comparing two quantities and how they're related to each other. So they're going to have a specific relationship to each other. Let's take a look at example 2. The times taken by Aaron and Bobby to answer an IQ question are 54 seconds and 2 minutes respectively. Find the ratio of Bobby's time to Aaron's time. Okay, so respectively, we talked about this before, about how respectively is just letting you know that they're listing the information in order. So they first told us Aaron and then Bobby, and then they first told us 54 seconds and 2 minutes. So that means Aaron took 54 seconds and Bobby took 2 minutes. So they're just listing it in order. So the ratio of Bobby's time, let's put B, to Aaron's time to A. Let's see, Bobby was 2 minutes because his was listed second, and Aaron's was 54 seconds. Okay, we're not done here because these two are not listed in the same measurement of time, right? One is in minutes and the other is in seconds. So remember, we are using ratios to compare their relationships with each other, right? So in order to best compare them, they need to be using the same measurement of time. We can't be comparing minutes to seconds because then that requires our brain to then compare minutes to seconds, and that's not as easy to compare. So it's probably easiest for us to change Bobby's into seconds so that they are both written as seconds. So we know that each minute has 60 seconds. So 2 minutes would be times 60, would be double that. So 2 minutes, let's see, let's rewrite this. 2 minutes. Let's see, each 1 minute has 60 seconds. Okay, so then we have minutes on top and minutes on the bottom. So that cancels. So at the end, it's really 2 times 60 to get the seconds. 2 times 60 is 120 seconds. And we're comparing that to 54 seconds. Okay, so really what we created was a little conversion right here. 1 minute is equal to 60 seconds. I put the minutes on the bottom so that the minutes can cancel each other out. So then all we're left with is 2 times 60, and then we have the seconds. So I have 120 seconds to 54 seconds. Let's simplify that by dividing top and bottom by the same number. Let's see, they're both even. They're huge numbers, so let me break it down by half first. So that's 60, and let's see, 54 divided by 2 is 27. Okay, can we reduce that anymore? Maybe by 3. They might be both reducible by 3. 3 times 20 will get me to 60. 3 times 9 will get me to 27. And then I think that's it. So the ratio of Bobby's time to Aaron's time would be 20 to 9. So yeah, Bobby took, let's say, almost or little more than twice as much time as Aaron. Because 9 times 2 is 18. He took 20 seconds 20 seconds. Bobby took 20 seconds for every 9 seconds that Aaron took. So a little more than twice the amount of time if we're comparing. Okay, let's take a look at another example. This one is just giving us ratios, and we got to write it in simplest form. So immediately, just like that Bobby and Aaron problem, I'm noticing my ratios are not in the same format, right? So for this first one, I have 1 to 1/3. One is a whole number, as the other is a fraction. We don't want fractions in our ratios because ratios are already written as fractions. So if I were to write A as a fraction format, that's disgusting, right? We don't want a fraction inside a fraction. So that's what we're trying to avoid here. We want to make sure that they're all whole numbers. Okay, so we want whole numbers. Because if we're writing as a fraction, it's just going to be a fraction within a fraction, and that's hard to compare stuff. And so C is written as a decimal. We want to get that to a whole number. Okay, so let's work on that. Let's start with A. I have right now 1 to 1/3. I have 1 and I have 1/3. I need to change 1/3 into a whole number. Okay, that means I'm going to need to cancel out that 3 on the bottom. So I'm going to multiply 1/3 by 3 so that those cancel out, because 3 divided by 3 is 1. So I end up with 1/1, which is 1. But if I'm going to do that with my fraction, I'm going to need to do that with my whole number of 1 as well. I can't just keep it lopsided, right? If I multiply this one by 3, I also need to multiply the other side by 3. So 1 needs to be multiplied by 3 as well. So I end up actually with 3 to 1. Or 3 to 1 like this, or 3 to 1 like that. Okay? That's my final answer. Because ratios are already fractions, we want to get rid of that fraction quantity. Okay, so I multiply by 3 to get it to a whole number of 1. So that means I had to multiply the other one by 3 as well to get to 3. Let's look at B. I have 2 1/4, and I have 3 3/5. Again, gross, we don't want fractions within a fraction of our ratio. So let's go ahead and change it into improper fractions to then see if we can change it to a whole number. To change this into an improper fraction is 4 times 2, which is 8 plus 1, so that's 9/4. And this is 5 times 3, 15, plus 3 is 18/5. So I changed both of them into improper fractions. Now, just like before, I'm going to multiply by my denominator so that I can, well, actually, let's make it a little easier. Let's get them both to the same denominator. Let's get them to a common denominator. 4 and 5 can both get to 20. So let's multiply 9/4 by 5/5, so I can get to the common denominator 20. So that becomes 45/20. And 18/5 will multiply by 4/4, so I can also get to the bottom of 20. And then 18 times 4 is 72. Let me double check that. 18 times 4. Yeah, 72. Okay, so now they both have 20 as their bottoms. So then I could multiply them both by 20/1, right? I can, if I'm multiplying one by 20, the other one also should multiply by 20. So that kind of cancels it out, and I end up with just their numerators of 45 and 72. So again, I changed to improper fractions. Then I multiplied them both by 20 because I got their common denominator of 20. So now I have 45 to 72. And now I can change it into a ratio of 45 to 72 of a fraction. Can I reduce that further? Let's see, 45 to 72. Can I reduce that? 9 maybe, right? Yeah, I think 9. Because 9 times 5 is 45, and 9 times 8 is 72. So 5 to 8, because it's a ratio, would be my final answer. 528 written as a fraction, or you can write it as words, or you can write it as, oops, you can write it with the colon, 528. Okay? Oof, that's messy. But remember, we wanted whole numbers because that's easier for somebody to understand the comparison. Okay? And then lastly, we have C, which is in decimals. So don't let that freak you out. We have 280 thousandths compared to 182 thousandths. Well, I can multiply them both by 1,000 to get them to a whole number. And that's basically moving the decimal 1, 2, 3 spots because there's 1, 2, 3 zeros. 1, 2, 3 spots. So again, whatever you're doing to one number, you got to do to the other, just like in a fraction. So I end up with 280 and 182. And if I were to change that into a ratio in fraction form, I can probably reduce it further. Let's reduce by half first. So half of 280 is 140. Half of 182 is 91. And then can we reduce that more? Ooh, I'm not sure. Let's see. I don't think so. Yeah, I think that might be it. 2 is not good. It's not divisible. I think 91 might be a prime number. That's why. Maybe 7 is the only one I can think of. Let's try it. Let's see. 7 goes into 140 20 times. 7 times 20 is 140. 7 goes into 9 once with a remainder. I think this is it. Let's see. 91 divided by 7. 13. Yep. You almost got away from me there. So the answer is 20 to 13, or 20 to 13 written this way, or 20 to 13 written this way, right? So changing it to whole numbers to compare is way easier than comparing it with decimals or fractions. If I say, oh, the recipe has a ratio of 0.28 to 0.182, you'll be like, huh? But if you say 20 to 13, you'll be like, okay, I can deal with that. I can deal with cups, but not decimals of a cup or a fraction of something. It's a little harder. Okay, so that's ratios, comparing two quantities, and you can write it 3 different ways. Basically treat it like a fraction and reduce, simplify.